Hello boys and girls, this is Mr. Kizik, and in this video we're going to be continuing to go over the quadratic functions, parts of a parabola, and how to graph it by using a table here. Now some of you are more ahead than others here, so if you are more ahead, then just fast forward the video for yourself to the point where your class was at the same point. So for you guys here, this first part, I believe one of my classes I had, numbers 3 and 4 were just for homework here based on time that we had. So with numbers 3 and 4, number 3, this parabola would be a maxima here because a is negative. Axis of symmetry would be 0 over 2 times negative 2, which is 0. So when I plug that in back into my function, my vertex is 0, comma 7. For number 4, since a is positive, it's a minimum. B is negative 8, but since the axis of symmetry formula is negative b, negative times negative is positive. So positive 8 over 2 times 1 would give me 4 here. And then to get the vertex, I plug in 4, and I get negative 7 as my y for my vertex, so 4, negative 7. Okay. Moving on to the graphing here. Now, how do we graph parabolas using a table? Obviously, the easiest thing to do would be using a graphing calculator, but we don't have that. And there's actually many different ways to go about graphing parabolas, but the one method is doing it by use of a table here. And there are 3 simple methods here, and it's kind of tedious when you think about it. And it's probably not the most valid way, but it is I don't want to say not sufficient, but it's just tedious, that's all it is. So for number 1, the first step is find the axis of symmetry in the vertex. So let's do that here for number 5. So number 5, the axis of symmetry, remember that formula is negative b over 2a. So here, x equals, what's b in my equation here? It's 0, so 0 over 2 times negative 3, which is just 0. So then my vertex, we plug in 0 for x, so my vertex is 0, comma 0. Now it's going to represent v as the vertex. So I'm actually going to plot that too, 0, 0. Okay. Now what does it say here? Number 2 says, place the vertex as the middle row in your table. So if I look here, there are 7 positions. So the middle one would be right here. I plug in 0, 0. And then when it says number up and down to complete the table. So like you're just going to go up by 1s after 0 here. So 1, 2, 3. And then down by 1. Negative 1, negative 2, negative 3. And then all you're going to do is plug in the values into your function. Now you may be thinking, well, wait a minute, Mr. Kizik. You're telling me I got to put in 6 points. And you could. There is nothing wrong with that. But remember this whole part here. What does the axis of symmetry mean? Now you don't need to draw this on your graph. I'm just going to show you here. The axis of symmetry, which we got x equals 0, which is this red line I'm putting right here. That means that the left side and the right side of my parabola, they are mirror images of each other. So what does that mean? Well, what I do to one side of the vertex, it's going to be the mirror image of the other side. And that's all I have to do. Just do one of the sides and realize the other side will be the same thing. So for example here, if I look, okay, so we got 0, 0. So I'll probably do the positives here because it's just easier to work with positives. So for this one here, it's negative 3. So right here, I do negative 3 times 1 squared. Well, that just gives me negative 3. Okay. So my point is 1 comma negative 3. Well, in reality, it's the same thing on the other side. Negative 1, negative 3. Bam, right here. Then I do the next one. Negative 3 times 2 squared. Now 2 squared is 4. 4 times negative 3 is negative 12. Now if you notice here, obviously we don't have the graph going to negative 12. Actually, first let me just do the mirror image, negative 12. Now I don't go all the way to negative 12 here, but I know it's going to be like a steep kind of squished U here, squished parabola. So when I draw this here, I'm going to be like, well, negative 12 is like somewhere all the way down here. So our parabola looks something like that. And then let's just continue the table here. 3. So negative 3 times 3 squared. 3 squared is 9. And then negative 3 times 9 is negative 27, which is the same thing for negative 3. And then again, graph doesn't have enough room there, so it's kind of hard to do. But that's how you do it, ladies and gentlemen. And then I also ask you domain and range for the graph. A nice little review of what we did before. Hopefully you remember domain is what x's are being used here. How far left to how far right. If I look at my graph here, I can plug in any value of x here. So my domain for, I believe, most of these here, all real numbers. Or you can use that fancy R. And then for range, well, range, remember, is your y values. How far down you go versus how far up you go. So there's multiple ways you could do this. If you remember, there was like the two methods I have here. How far down do we go? Well, it's negative infinity. Less than y, which is less than, and what's the highest I go here? 0. That was one way you could do it, or you could have just said y is less than or equal to 0. Either one would have been fine here. Alright, let's look at number 6. So again, first step is find the axis of symmetry and therefore the vertex. So I'm going to do negative b. So what's b here in my problem? It's negative 6. So negative and negative makes me positive. So 6 over 2 times a. 2 times 1. So 6 divided by 2 times 1, which is 3. So then when I plug it in, I will have 3 squared minus 6 times 3 plus 11. So this is going to get me, let's say 3 squared is 9, minus 18 plus 11. 9 minus 18 is negative 9, plus 11 is 2. So my vertex is 3, 2. So I'm going to put that dot here, 3, 2, right here. And then I'm putting it in the middle of my table. And now all I'm going to do is, as it says here, go up by 1 here, 4, 5, 6. Go down 1, 2, 1, 0. And plop my points here and plug it in. And again, what you do to one side is going to be the same thing for the other. So, make it easier for yourself. Use numbers that are easier to plug in. Personally, I probably do these top numbers here, 0, 1, and 2. They're going to be much smaller numbers to deal with. So this one I'm going to have 0 squared minus 6 times 0 plus 11. So I'm going to get 11 here. Yeah, 11. Which is also going to be the same thing here for 6. Again, I don't have 11 somewhere down here, so maybe some other points. Because how far we go here? 1, 2, 3, 4, 5, 6. We got 8. So we got 3 more. So it's somewhere down here. But again, we want to be as precise as we can. Let's do 1. 1 squared minus 6 times 1 plus 11. 1 squared is 1. Minus 6 is going to be negative 5. Plus 11 is going to be 6. 6, 6. Well, that helps us out actually a little bit because 6 is going to be able to graph. Yeah. Sorry, this graph this goes up here. It's a U shape. I don't know why I was pointing down before. Anyway, so I got 1, 6 here. So 1, 1, 2, 3, 4, 5, 6 right here. And then 5, 6. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6 right here. All right. So that helps us there. And then the last one, 2. So we got 2 squared minus 6 times 2 plus 11. 2 squared is 4. 4 minus 12 is negative 8. Plus 11 is going to be 3. 3. So I got 2, 3. And I got 4, 3. Now this one's a lot better kind of graph here because I was able to plot more points. Alrighty, so now if I do the domain here, it's going to be, guess what, all real numbers again. And my range now, again, what's the lowest, what's the highest? The lowest here is 2, and my highest is all the way to infinity. So how do I write things that are bigger than 2? Y greater than or equal to 2. And there you go. That is how you graph a quadratic function using a table here. So what I want you to do is I do want you to do numbers 7, 8, and 9 here. And just say, yep, 7, 8, and 9. So you can cross off 10 for yourself here. I don't know why my page moved, but you can cross off 10 here. And then I want you to do these 4 also here, okay? So try those next 3 there, and then do these 4 also, right? And with these 4, I do ask basically for everything that we did here. Let's put it all together. Let's find either it's a minimum or maximum. Again, that all depends on A. Axis of symmetry is using the formula there. And remember, it's always x equals. You just give me a number, that means nothing to me and will be marked incorrect. Vertex is a point. Domain, hopefully you've seen domain. What's the domain all the time with parabolas? And range, highest versus the lowest. Again, if you have any questions or concerns, please feel free to email me. This is Mr. Kizik signing off.